So, what I would like to do now is bring up our speaker, Blake Burch from Shipyard.
Hey everyone.
All right.
Great. So I'm super excited to chat today about setting up a modern data stack for your startup. Now, this has been a real big marketing term that's come up in just the past few years for a modern data stack. So I think it's really important to understand how, if you set things up correctly and you get the foundation right, you're able to use data to really scale your startup to be able to grow for years to come. So I'm Blake Burch. I'm currently the co-founder and CEO of Shipyard. We're an easy-to-use data orchestration tool for data teams, and my goal with this presentation is to try and be as vendor agnostic as possible, let you guys know all the different tools that are available, including open source tools that you can use throughout setting up a modern data stack. I was previously head of data for PMG Digital Agency, where we were building end-to-end data solutions for Fortune 1000 brands, and the Shipyard technology was actually spun out of all the things that we were able to help do for some of these clients at that agency. And over the course of me working with data, I've evaluated data setups for well over 60 companies. So I've seen some really good setups and I've seen some really bad setups, and I'm excited to share kind of what I've seen work the best for organizations. Now, in this presentation, we're primarily going to be going through what the modern data stack is, what the different stages of data operations are, how your data usage will evolve over time, and what the end state of your data should look like if you get everything right. So, kicking things off, the modern data stack needs to have a really clear definition. And for me, it's a suite of cloud-native technology that makes data actionable by reducing time and complexity in order to be useful for an organization. The ultimate end goal is to be able to uncover new opportunities and increase the organizational efficiency. So with the modern data stack, in that definition, we have to kind of think through what are the core principles. It's not just new technology, shiny things, set up data quickly. It really focuses on a few things like, first, centralizing all of the data that you have in a single data warehouse. You want all the information, whether it's HR, whether it's product, whether it's working with support, all that information needs to live in one spot. The second principle is something that is deemed ELT. If you're not familiar with this term, ETL stands for extract, transform, and load. It's the old way of working with data where you extract data from a service, you transform it using your own business logic, and then you load it in your data warehouse. The modern data stack kind of flips this around and says, instead of transforming things before it goes into my data warehouse, I want to load as much raw data as possible, and then after the fact, I want to transform it and change that over time so I can see how my data has actually continued to change over time. Another main principle of the modern data stack is to minimize the overall engineering effort, which means you're going to see a lot of solutions that are somewhat no code or low code in order to be able to easily move the data together. You kind of see a trend towards things becoming very declarative instead of imperative. So you only have to think about accomplishing a specific objective instead of figuring out exactly all the pieces that it takes to get that in place. But that doesn't mean that everything is just being washed away with no code and low code. The modern data stack is really emphasizing engineering best practices as well. Things like logging and testing and documentation, version control, environment management. We're really starting to up the ante when it comes to working with data to make sure that things are extremely clean and extremely well controlled within the organization so that bad data isn't deployed as often as it might have previously been. So with that kind of definition of the modern data stack, where you start is bringing in a data engineer, especially if you just need access to data. There's a lot of organizations that try to hire a data analyst or a data scientist off the bat, but they spend 90% of their time at that point just trying to get access to the data, just trying to clean it, and they're not doing any of the really specialized things that they are capable of doing. And this builds up a lot of resentment, but it happens all the time because people are like, oh, I need someone to work with data, I'll get a data scientist. Data engineers are extremely valuable to have because they focus on trying to make sure that clean data is accessible for everyone in the organization, and they figure out how to centralize it using engineering best practices. So that first step of setting up your data means that you have to figure out some place to store your data. And we recommend going with a cloud data warehouse. You want something that has no infrastructure to manage. You throw data into it, and you're able to run multiple different queries against it simultaneously and have that scale automatically. A good cloud data warehouse separates the compute from the storage so that as your data scales, you can run thousands of queries against it without it breaking a sweat, and it will be able to work with terabytes and terabytes of data that need to be processed. You want to make sure that this cloud data warehouse also can serve as a centralized source of truth for all the information in your organization. You want to make sure that you're able to govern the access to this data by making sure finance only has access to finance data and marketing only has access to marketing data. So you need good schema, table, and view controls. As well, you want to choose something that has columnar storage. There's always been big arguments about should I choose NoSQL or a SQL database. I highly recommend, if you want to scale things very quickly, to use a SQL-based database. And using NoSQL has its purposes, but it can add a lot of complexity and overhead that makes it harder to start actually using your data. So when it comes to choosing a cloud data warehouse, the leaders right now are BigQuery and Snowflake. BigQuery is hosted on the Google Cloud Platform, scales automatically for high data loads. Snowflake can run on any cloud platform and also scales with high data loads. Both of these give you a lot of control to optimize how your queries run and ultimately try and reduce cost. But as your organization grows, you're not going to see your database get bogged down. Some people might wonder, I'm using AWS, should I use Redshift? That's their cloud data warehouse. I actually wouldn't recommend it. Unless some things have changed recently, Redshift has a hard time scaling with more queries, and it ultimately puts the overhead of you building out a lot of like server capacity in order to make sure that your database grows with your data needs. So at this point, you've got some place to store your data in a cloud data warehouse. The next thing that you want to do is tag everything. And when I say everything, that means every event that you can possibly capture on like your website and your product. You want to know what pages people visited. You want to know where they're clicking, where they're scrolling, what they're filling out on a form. All this information is extremely valuable to have. But there's new systems in place when it comes to tagging your data that really help make this extremely powerful. Previously, we were kind of in a situation where if you wanted to have Google Analytics on your site, and then you wanted to have Amplitude, and you wanted to have Hotjar, and then you wanted to have HubSpot, each of these would capture their own data separately and just have it live in their own tool. Now we have data tagging tools that allow you to track all these events and then pass the events to these tools. And that means that you get a single source of truth for events. So if a single customer has ID ABC, then they're going to have ID ABC in all of the SaaS tools that you use. These tools also make it really easy to be able to incorporate new SaaS tools and send that consolidated data through them. But also, a really cool part of this is that you get the backfill data. So that means that if you change a decision 2 years down the road, we don't want to use Google Analytics, we want to use Adobe Analytics. Instead of having to start from scratch, you can actually send all of the event logging data that you had stored previously through this new tool. And that means that you kind of have a seamless transition because SaaS tools are going to come and go, but you're able to make sure that they're up to speed with all of the existing tracking that you had in place. So our top recommendations for data tagging are Segment, which is what we use at Shipyard. It helps you connect to multiple different types of tools and send consolidated data through them. But an open source alternative for this is RudderStack. I've heard great things about it. I haven't personally used it myself, but it's an easy way to do that sort of event logging and make sure that data is being sent to all of the SaaS tools that you're using in your business. So our data stack currently looks like this. You're tagging the data and sending it to your tools, and you have somewhere to store your data. Now we have to try and figure out how to connect them together. And so the next step is to figure out how to extract and load raw data from your SaaS tools. So the main things about like data ingestion here is that you want to make sure that you are finding a tool that can just seamlessly move data from those SaaS tools. You don't want to have to go through much setup. You want to say, hey, I want these pieces of data from the vendor. Just dump them automatically into tables in my data warehouse. And you want these data dumps to be totally automated every day, but hopefully every hour or every few hours, so you can make sure that you're refreshing the data frequently. All of these tools that are out there, they make it really easy to get data into your warehouse, which used to be a month of undertaking. But they might not have access to every single vendor you use. That's okay. As long as they have like 90% of the vendors that you use, it'll make it really easy to be setting up a modern data stack. And the big thing here about choosing a data ingestion vendor is that you want someone that can handle the schema changes for you. I can't tell you how many times I dealt with situations where, oh, Facebook changed their API today and didn't tell anyone, so now there's a new column that we didn't account for, or the definition of a specific value changed over time. There are teams of like tens and hundreds of engineers for these data ingestion platforms that just handle these API updates, and you don't want to bog down your engineering with being responsible for this. You really want to make sure that you're choosing an external tool for the data ingestion. So our top vendors that we recommend for data ingestion are Fivetran, which is one of the leaders in the space, has connections to pretty much everything you can imagine, and it's what we use at Shipyard. But an open source alternative that's been rapidly rising over the last year is Airbyte. They just launched their cloud product, and they kind of cater to the long tail of vendors. So if you use some really obscure SaaS products, you'll probably want to look at something like Airbyte, which might help you be able to load that data in more seamlessly. But either way, you need one of these data ingestion tools to make sure that all of that information from your SaaS tools is being centralized in your data warehouse. And at this point, we now have at least a full picture of grabbing the data, ingesting it, and then storing it somewhere. But currently, it's not really usable. It's very raw. It's all the information you could possibly imagine, and we need to find some way to really like tone it down and figure out how it can be usable for our business. And when it comes to actually figuring out how to make your data usable, that's when you need to start seeking out an analytics engineer. It's a brand new role that's been kind of making its way into the space over the past few years. But really, it's someone that has engineering best practices in place, can write quick Python scripts, knows SQL in and out, but uses the Git and version control in order to manage these systems. Analytics engineers are great about acting as sort of a liaison between different teams to make sure that they get access to the data that they need. So I would recommend, once you're at this stage where all the data is together, to seek out getting someone that's an analytics engineer. But the data engineer can still get you through some of these next few steps that we're going to be walking through. So you have your data stored. The next thing that you really need to be focusing on is transforming that data that lives there. And when you're looking at transforming the data, this is one of the key elements that you have to get right and you have to spend a lot of time on. You need to scope out, like, what are the KPIs that we want to define? What are the types of information that we want to pull from all the vendors we're working with? How do we want to join this data together and look at things holistically? Data transformation is all about turning that raw data into something that's usable for each of the teams in your organization, because you don't want anyone touching the raw data except for the data team. Everything that you transform should be defined in tables and views in SQL. SQL is the language of data. You want to do all the processing directly in your data warehouse. You don't want to be using tools that have kind of solutions where you transform things by one rule at a time visually. I'm not going to name any specific vendors, but I would recommend staying out of that space because it makes it really hard to recreate the business logic that is integral to making sure that you have usable data. You also need a tool that knows how to execute all the SQL in order. This gets really problematic where you have things like, let's say if you need a table for customer data and order data, and you need to mix it together to show orders by customer, and then maybe you build a view that shows your top customers by order for the last month, and then another one that shows them for the last year. When you have all of these connected together, the problem with SQL is that if you update something in the middle, you're going to have to drop everything and recreate it, and trying to execute SQL in order manually is really difficult and error prone and causes issues into downstream things like visualization tools. In the data transformation process, since this is the data that should be usable by everyone, you also want to take the time to apply data tests. Things like, is the data null or not? Should all the results be unique? Should it have data for every single date? Should it be between specific number ranges? These are all things that you want to define while you're transforming the data. And you want to take this time also to document the content of the data so everyone knows what's accessible. And if they want to report from Google Ads, that they know exactly what table is going to have that information. And as you're building out all these tables and views in SQL, this gives you a good opportunity to govern data access and make sure that you build out finance tables in a finance schema and you give those users only access to the finance schema. Same thing for marketing. And you can really fine tune the controls to make sure that everyone only has access to exactly what they need. Now, for all of these, I provided multiple different tools, but for data transformation, there's one clear winner in the space, and that's DBT. DBT stands for Data Build Tool. It is an open source tool that is just phenomenal at managing the transformations in your data warehouse and ensuring that you have access to the right data. And I don't have enough time to go in depth for it here, but just to kind of give you a brief overview of what it allows you to do. DBT is a Python package that gets executed as part of a command line interface. In DBT, you define all of your SQL files for views and tables like this, and you can use Jinja templates in Python in order to build out macros and dynamic SQL. And by using these Jinja templates, it automatically creates the order of how all these SQL queries should be executed. And it can get really complex, even bigger than this, but DBT takes care of all that so that whenever you run DBT in the command line, it actually goes through and executes things all in the right order, and it gives you a view to say, hey, this was successfully created, this ran into an error, and it gives you the results of all those SQL queries that you just executed. Alongside that, they have YAML files in place so you can build documentation to where you state, hey, these are all the tables and views that I have. These are all the columns in those tables and views. These are the tests that it should run on each of those columns. And this automatically generates a document that you can host and show everyone in the organization and have them search for specific tables, how they're built, what the underlying SQL is, the data types, all that good stuff. It's an extremely powerful tool, and if you're not using it for your transformations and how you're actually building out tables and views in your organization, I recommend checking it out. It doesn't take too long to get up and running. They have great tutorials, but it's really powerful for making sure that everyone in your organization has access to the right data, and all of this can be version controlled so that you can make sure you're never deploying bad data to people. So with your data transformed, your data stack now looks like this. Once it's in your data storage system, DBT grabs the data and then creates tables and views that live back in your database so that everyone can access this information effectively. Once you have those clean views and tables, then you're able to start actually acting on the data and doing something with it. And the first step that a lot of teams take is figuring out how to visualize your data. And I want to throw up some warnings here that a lot of people consider visualization to be the last step. They build a dashboard and they move on. But really, visualization should be integrated into part of your process for decision making if you want it to be truly valuable. A lot of data teams get frustrated because they build dashboards that only get used for a week and then get tossed to the side. You need to make sure that you're really thinking about what exactly do I need to track over time when I build out a dashboard? How can I use this dashboard to have everyone align on KPIs and the direction of the organization? How can we integrate this into daily decisions during stand-ups, during weekly, quarterly, monthly reviews? And another big aspect here for the data visualization is that you don't want to build transformation logic here. All these tools have ways to say like, hey, you can just tweak your data slightly for the visualization. You always want to do that in the previous step for DBT and then have the visualization tool actually pull from that table or that view. That means that you can switch out data visualization tools and you're still able to build out the same visualizations without having to recreate any logic because all your tables and views live in your data warehouse. So when it comes to data visualization, these are our top recommendations. If you're growing really big, you're probably going to want something like Looker, which lives in the cloud and integrates easily with Snowflake or BigQuery, which we recommended. It has good templatization and all that stuff. If you want something where anyone in the organization can access the data and build visualizations, I really recommend Data Studio. We used that a lot at PMG previously, and it was great for helping account managers be able to explore the data and to really kind of self-service any data questions that they had. And an open source option out of all this is Metabase. It's what we use at Shipyard, and they have a really interesting model where you can ask questions of your data and use a visual drag and drop interface to build out visualizations, but you can still analyze it in SQL. And so these are great options for having those static dashboards that refresh every day, as long as you incorporate that into your decision making. If it's just your data team that's going to be making and managing dashboards and they need a way to explore, I would actually recommend any sort of notebook tools. I didn't put anything in here, but great notebook tools are things like Count, Hex, DeepNote, and if you want open source, just using Jupyter notebooks. But these are great options if you want to explore your data visually initially. And so at this point, you've got a full cycle, and like I said, most people generally stop here. They only visualize the data and they make a few decisions off of it, but they're not really getting the value out of their data. In order to make this actually increase efficiency in your organization and make operations more effective, you want to ensure that you take these next two steps really seriously. So first off, you want to try and send the data that you've captured in your database back to all the SaaS tools that you're using. This is currently being called reverse ETL in the data space, where ETL is taking data from SaaS tools into your database. This is taking data from your database and putting it back into your SaaS tools. I like thinking of it as augmentation. You're basically trying to make sure that every tool is augmented with other tools' data at the same time. And the goal here is to try and sync source of truth data to marketing, product, sales, and support, so that everyone can operate off of the same data while still using the tool that they already use. So great examples. Maybe support has a conversation with a customer. Now you can have that pop up in the sales CRM so that they know exactly what they were having issues with or what they wanted to dig into. Or maybe sales just recently had some conversations with people. Marketing can build an audience off of that list in order to try and better capture them, because maybe they never visited the site, but they're just getting information from like from a conference or something like that. There's a lot of unique opportunities here that if you're a product-led growth company, you really want to be using reverse ETL to get all this data into your tools. And again, I have to emphasize, don't build a transformation logic here. These tools allow you to do that, but I recommend building everything directly through dbt in that transformation step to make sure that you can switch these tools out at any point and you always have access to the data that these reverse ETL solutions are using. So the top tools in this space are HighTouch and Census. They are both SaaS tools. Recommend both of them. I would check them out equally to see which one fits the bill better for you. And then an open source solution for this is Grouparoo, where you would be able in all of these to take SQL views or tables and map them back to the services that you use on an everyday basis to keep all your teams in sync with the same data. And at this point, your entire data ecosystem becomes a loop. You've transformed the data that lives in your data warehouse. You then augment your existing SaaS tools with the data that you stored and transformed, and now they're feeding each other. So that means that not only is your data warehouse the central storage solution, but all your tools have the information from all of the other tools as well as their own. And it starts to become really powerful to where you can scale things. But the next step is where things really start to take off. And that is really where you start incorporating data orchestration. Because so far, what I've shown you, these arrows are all in theory. They're implied about the direction that the data moves, but none of these tools are actually connected together. Typically, what teams are doing is building out trust-based systems to where they're ingesting the data at 6 a.m., they're transforming it at 7, and then they're augmenting it and having like data extracts for visualization at 8. But the problem is, what if your data only takes 15 minutes to load? Well, then you're just sitting around and waiting. So you have a 2-hour process that maybe you could finish in 30 minutes. Or what if this data takes too long to load? It takes 2 hours. Well, now you're transforming incomplete data and potentially visualizing and augmenting off of that incomplete data. You also have problems where if something gets loaded in incorrectly, or not all the data gets loaded, that all of these systems will continue to run, and you'll be deploying bad reports, bad visualizations, bad data back into your systems, and you want to avoid that overall. And so the real step with data orchestration is to tie everything together and try and make sure that you're able to see end to end how all of these different data tools that you're using fit into the greater picture, so that you're ending up in a situation where you know exactly how something like Fivetran will then talk to DBT, which will then talk to Looker, and which will then talk to High Touch or something like that. And if something goes wrong, you'll know about it immediately, and you'll be able to prevent downstream processes from running. So instead of just having everything run on its own schedules, a problem upstream prevents issues downstream. So nobody gets bad data, nobody finds errors, nobody is losing trust in the information. And good data orchestration also has really heavy error handling, which means that it can automatically retry stuff if it goes wrong. In other systems, you might just be stuck and know about the issue and figure it out the next day. So data orchestration also, beyond all of the aspects of connecting your tools together, helps you fill the gaps with one-off scripts. And when I say fill the gaps, that's things like maybe you want to test your data in between each of those different steps with a package like Great Expectation. Or maybe you need to deliver reports to your clients, or you need to deliver your product data to a vendor that like runs with marketing feeds, or you want to anonymize your data before anyone has access to it in the data warehouse. These are all types of fill the gaps solutions that data orchestration is great at fitting in. And even things like if your data ingestion platform doesn't have access to a specific SaaS tool, you can build out the ingestion process as part of data orchestration and still connect it all together. So it's a great tool to kind of connect everything together and allow you to do anything you want with your data. But the really powerful thing is that it starts letting you action on the data in proprietary ways, being able to run scripts in Python and Node and Bash to deploy machine learning models, to update APIs, to send off requests to different services like Lambda that you might be using. There's a lot of different things that you could do with it, but orchestration helps make that possible. And it really just gives you flexibility to be able to operationalize on your data. And that's the key thing. You needed all of this foundation to get your data in one spot, but once it's all there, your opportunity is unlimited for being able to have engineers and data teams alike figure out how to use the data to scale operations in the business. And so the two tools here are Shipyard ourselves. We're a cloud-hosted platform that has low-code templates but lets you run your own code. And you also have an open-source solution like Airflow that allows you to string everything together in Python itself. And so just kind of like a brief overview, just like I did for DBT, to show you everything that you're able to accomplish in a solution like data orchestration. You're able to select all the different data tools that you use and fill out just a few like form inputs to say, hey, I want to download the data, upload it, run a query, or something like that. You're able to visually string together all the different tasks that you want to run together into a larger workflow. You're able to see the status of how things run over time. You're able to click in and see the underlying like output to verify how things broke or how they were successful. And you should be able to do things like have alerts in place so you can get emails when something breaks, or have automatic retries. And when it comes to the automation aspect, being able to set up multiple different schedules and being able to drive event-driven workflows with like API or with webhooks. So that's really what data orchestration is for and what it's really powerful for. And I mentioned this as the last step, but it can happen at any point after you've built out ingestion. It just matters of where you are in your journey and if you have those fill-the-gap solutions that you need to start putting in place. So the final state of your data stack starts looking like this. You're able to tag the data, get it all into all your different SaaS services, ingest it on a daily or hourly basis, store and transform it, and off of that transformed data, action on it, visualize on it, augment on it, and tie all of these different systems together through a data orchestration platform. And then at this point that you have all this set up, that's when you can start hiring things like data analysts or data scientists to explore your data. You want to make sure that you have this foundation in place so that when you hire a data analyst, they have data to dig into to try and find opportunities for the business. And that a data scientist can truly spend their time focusing on deploying multiple different models and testing them all out at the same time to verify what's going to drive the most impact for your business. And so there's a great article of this on DBT that I'm happy to share over. But you can find out what a data organization should look like. The optimal structure that most people consider is about 2.5% to 5% of your personnel should be data focused. That first hire should be data engineer, second hire analytics engineer, third a data analyst or a data scientist, and then you need someone to kind of manage the overall operations. They can go into the CTO or the CEO, but it's important to have data divided as a division from just being solely engineer focused, especially if you want to drive the most value that you can from your data operations. So summing everything up that we talked about, this was a quick high-level presentation to give you information of where you can start. You first need to figure out where to store your data somewhere. You need to figure out how you can tag everything and load that in, extract and load raw data from your tools, transform it with something like DBT, visualize that data, send it back to tools with reverse ETL, and then tie it all together with data orchestration. So at this point, I'm going to open it up for any questions, and I'd love to answer and see kind of the issues that you guys might be having getting your data set up for scale. And so it looks like we already have a few questions up here. And so the first question was, what do we use for scheduling? Airflow, I think that came in probably early. No, we actually built out our own proprietary scheduling system for Shipyard. Everything is custom built on AWS with Go. It's scalable and it's just easy to use. We heard that there were a lot of problems of taking months to get up and running with Airflow that we felt like we could provide a better option there. But happy to provide more information about that afterwards. Does DBT support JavaScript? It does not at the point right now. It is built in Python and executed entirely in Python, but it's executed as a command line interface. The thing is for DBT, it's primarily like a Python package, but you're writing everything in SQL. It's mostly SQL and YAML files with Python under the hood. If you're looking for something that does support JavaScript, I could put you in the direction of Dataform. I'm not as familiar with them. They did get bought by Google a few months back. I'm not sure if they're letting people use the platform right now, but I do know they use JavaScript under the hood. But either way, I would try using something like DBT just because it's kind of becoming the industry standard for transforming your data. And yeah, is there a comparable platform that does that? I think that answers that question there. So Dataform is what you'd want to look into on that side if you absolutely have to use JavaScript for transforming your data. The other question was for RudderStack. Airbyte, DBT, and the free open source tools, are there hosted and fully managed versions? Yes, for almost all of them, there are hosted versions of those products. I think the only one that might be questionable is Airbyte. Like I said, they just released their cloud product. I think they have a wait list for it, so it's not quite there at the moment. But you'd be able to use those hosted solutions or just use the SaaS solutions at that point, whatever you choose. And for the segment alternative that Blake mentioned, the recommendation there is RudderStack. They do a lot of the same things that Segment does with event logging and sending data to all the different SaaS tools that you use, and they are fully open source. All right. I think that hit all the main questions. If anyone has any others, feel free to shoot them over right now. All right. It looks like there are no more questions. So, final thing is, if you're here for this presentation, please connect and reach out with me. This is all my information of how you can find me. I would love to just sit down and chat. I'm here in Austin and really enjoy just having conversations about where the data ecosystem's going and how data operations is changing for startups. So, looking forward to hearing from some folks. Thanks.